Okay, so we have started informed search, and informed search we have seen best first search, which uses a heuristic function Fn. Today we are going to see A star and AO star algorithm. These are two different algorithms. A star is a advanced version of best first search or a special case of best first search, whereas AO star is a modified A star algorithm applied to a different kind of problem. Okay. And what we have learned, best first search and A star algorithms are mostly suitable for finding out the least cost or the best cost scenario, or you can say in a route math, finding the best route. Okay, so mention in your note today's date, content page. Today's date 8th August and topic is A star and AO star algorithms. Write down. So we'll start with A star. So as I said, A stands for algorithm and star stands for optimization. You know, the best optimized value. In your soft computing and optimization, you might have learned that star means the best value, the optimized value. F star means the optimized value of the function. So A star algorithm is an informed path finding. So these are basically used for path finding and graph traversing algorithm. So if in the exam a short question is asked, what is the difference between A star and AO star with respect to their applications, then you need to write A star is for path finding and graph searching, whereas AO star is for AND or graphs. To find the shortest path between the starting node and a goal node. It balances the exact tracking of Dijkstra, you can say Dijkstra's algorithm with the forward looking of greedy best first search. Why it is called greedy search? Because best first search in the next iteration finds the best node. For example, least cost node. Least cost practically applicable node. That's why it is called greedy. The moment it finds a better one, it takes that. Okay, that's why it is called greedy. So what is the algorithm? At each step, A star selects the next node to expand by minimizing a total cost function. Mention this in your note. In A star, we use a heuristic function Fn, whereas in best first search, the simple best first search, we use a heuristic function Fn, which is, last class we saw a problem, which is the distance from the goal. Okay, whereas A star uses a heuristic function which is a combination of the distance from the goal as well as some cost associated with the nodes itself. Okay, known as the HN. So here where Gn, write down, where Gn, just mention Fn is equal to Gn plus Hn, and then write down Gn is the exact cost to travel from starting node to the current node, and Hn is the estimated heuristic cost from node n to the final goal. Okay, and F is the total cost. Okay, so A star maintains a collection of nodes. The open list is a priority queue tracking the discovered node, awaiting evaluation, and closed list which you have already evaluated. Open list means nodes that you are going to evaluate. It's a queue. That means which has entered last, which will come out first. It's a queue. Stack means last entered. It's a LIFO. Start means LIFO. Last in, first out. Whereas queue is FIFO. First in, first out. Okay. It's nothing. Open list means the nodes you have not yet explored. Closed list means you know that if you go to this node, what is the cost. Okay. So is it clear? The difference between best first search and A star, the difference is that best first search uses a simple heuristic function Fn, the distance from the goal, whereas A star uses two such. It's a combination of cost. One is associated with the distance from the goal. The other one is the cost from the next node. Okay, that we'll see in detail. Okay, now we will do a comparison between BEFS and A star. So evaluation function is HN. Okay, whereas here the evaluation function is GN plus HN. So path cost, it ignores the past path cost, the last path cost. Okay, it ignores that. Whereas it tracks cost from the start. It's like A star can revise cost also. Okay, A star can revise cost based on the current development. That we'll see. Optimality, sometimes find suboptimal routes. It may not be the best one. Whereas A star guarantees the shortest path. That means it is because of the star. The star signifies that if you use A star algorithm, you are guaranteed to get the best path. Okay. Completeness, sometimes it can get trapped in loops and may not reach the final goal. Whereas it always finds if there is a solution. Memory footprint, moderate. It is high because even though you have a closed list where you have put all the nodes, you need to remember what was the cost associated with that. Okay. Okay. So this is the same question. Is it the same question that we solved last class? Right? The same question that we have used hill climbing. Hill climbing, we saw that it simply reaches here, right? Because it is the next best. Then it gets stuck there because hill climbing will only go to the next node if it is a better one. In that case, better means lower distance from the goal. Hello? Remember, all of you listen. How to solve this problem? The first point is finding the distance from the goal. Right? So that day, we found the distance from the goal. For example, node K. What is the distance from the goal? 1, 2, 3, 4, 5. Right? The distance is 5 units from the goal for the K. So you are actually finding out the distance. For example, B. What is the distance for B? Tell me. From the goal. Correct? 13. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B ra 10 hela. E ra, what is the distance from the goal? E. All of you. E ra calculate karo. Now goal calculate karo. Ebe first hoche distance calculate karo from the goal. For all the nodes, you calculate the distance from the goal. Okay? So these are the distances from the goals, and BEFS, that means best first search, will use only these distances. Okay, best first search uses only these distances, whereas A star will be used something else. It will use, in addition to these distances, it will use something else. Okay, so what is that? That I will see. Okay, so what are the questions? The question is a map on a grid. Each time 1 plus 1 size is shown. The locations are at the grid points. The locations, look, hey, the locations are at the grid point. So that's why you have to take that distance. Okay, they are at the points, at the grid points, and are connected by two edges. Two-way edges are roads, and each edge has the cost that is same in both directions. The start node is S and the goal node is G. Move quickly. Movegen function money, it will simply return the next nodes which are connected to the current node. Right? and in alphabetical order. The remove scene procedure, it's already okay. Only this Manhattan distance will be used as the heuristic function. Okay. So, whatever you have calculated is the Manhattan distance from the goal. BFS uses only that distance. Okay. Let's see what A star uses. Okay. So, for this question, I have also provided the answers in the extra. So, here you have to use best first search, sorry, breadth first, depth first. Best first we have already seen in the last class. Then you have to use A star. So let S be the first node to be defined. Determine the next five nodes defined by A star. We'll see one by one what nodes A star finds. Okay. In the last class we have seen what node best first search finds. So for the 5 nodes, list the F values. Okay. So first we have to see how to compute this F values. Okay, we will compute this. Okay, so for A star, what you have to do? You see here, note it. While you are finding out the difference between best first and A star, note that A star is actually revising costs. It is revising costs based on the next node. For example, the first node was CHIK we gave, so it will, the first move gen function will return CHIK, okay, right, CHIK, so graph ro dekhla mein likh CHIK, so it will go to K because the K distance is 5, right, K ro distance is 5, okay, but A star will revise the cost of the node after K yes. Now, after S we have gone to K, which is the distance is 5. Okay. Whereas from K to N, the distance N, what is the distance from the goal? 6. Okay. So now, what is the total distance from S? That is 11. Total cost now is 11. Okay, so it will find an alternative path where the cost, whether the cost can be less than 11 or not. It will do that. Okay, so how it does that, you have to see, you have to do it yourself. Otherwise, you won't understand. That we will discuss in Monday. Okay, so that is A star. It actually revises the cost. BFS is not revising the cost. It is simply using the distance from the goal and finding the next best. Whereas A star, for every node, it will revise the cost. Okay. Okay. Next, we will move to AO star algorithm. Okay. Next, we will move to. Before moving to A star, you try A star now. Okay. For a few minutes, you and see the solution in the extra. Okay. Okay. So BEFS and A star, BEFS, best first search, and A star algorithms, they find the shortest path. Okay, shortest path from source node to goal node by means of some heuristic function. Okay, by means of some heuristic function, which can be either the distance from the goal or it's a combination of another heuristic measure. Okay, whereas AO star works on a completely different kind of problem known as AND OR graphs. Okay, so AND OR graphs look like this. You have a source node, so if you go to B, you have to go to C, or you can go to A, right? So either you can go to B and C both, or you can go to A. This represents the solution of a problem that can be solved by decomposing them into a set of smaller problems. So either it is S can be converted into either A or B and C. Okay, and arc may point to any number of successor nodes, all of which must be solved. All of which must be solved. So if you want to use this path, you have to solve B and C both. So AND arcs are indicated with a line connecting all the components. Each K connector is directed from a parent node to a set of successor nodes. So here parent node is X, whereas successor nodes are A, B and C. Draw it. Parent node is S, successor nodes are A, B and C. Okay. A solution graph and an adder graph is analogous to a path in an ordinary graph. So it's a solution path. Adder graphs are also known as hypergraphs. Okay, these are also known as hypergraphs, and these are known as hyperarcs. These are known as hyperarcs. Okay, because those are not between the nodes. Normal arcs are between the nodes, whereas these are not between the nodes directly. These are between the edges. So these are known as hyperarcs. Okay, we'll go to the next slide. Okay, see, transforming AND graphs. Suppose this is a AND graph where you have, listen carefully, this node can be expanded into either A or B and C. Now we can write like this. This can be expanded into either A or D, where D is a combination of B and C. Right? So such type of conversion or transformation is allowed for AND graphs. So how to search AND graphs? So we need an algorithm similar to the best first search, but in that case it should have the ability to handle the AND arcs appropriately. Okay. So each arm of the AND arc must lead to a solution node. So if it is an AND arc, that means each of those nodes will lead to a solution node. That's why it is AND arc. For example, here, if you see this graph, okay, so if you take this path, then you have to go to D, you see here, S to E, H, okay, no, S to E, E to D, because it's an AND graph, S to E, E to D, then D to F, F to G, if you follow this path, okay. So this is one path. Okay. The other path is this, the OR one. Okay. Now the question is, which is cheaper? Which path is cheaper? Okay. So how to find that? Which path is cheaper? Right? So in this AND graph, you have two different ways of reaching the goal. Which one to choose? So for that you use the algorithm AO star. So which one to choose? So which one to choose? So can be obtained by AO star. Okay. So the objective of AO star is to find the solution path in AO star in AND graph. Suppose a 2-mark question is asked to you, what is the objective of the AO star algorithm? The objective of AO star algorithm is to find the solution path in AND graphs. Whereas the A star and BEFS, their objective is to find the shortest path, okay, between goal source and goal node. Okay. So these are the details of the algorithm. So as usual, we do bottom of cost revising and connector marking. Okay, go through it. Okay. So similar to A star, you see here, if you understand this slide, you understand AO star algorithm. Okay. You see here. Now suppose from source to this node A equals to 5. Each edge cost is 1. Look carefully. Each edge cost is 1. So what is the total cost to S when it chooses this path? The cost is 5 plus 1 6, right? Because this is the cost of the edge and this is the cost of the node. So total cost is 6 here. Okay. However, when you go to the next node, okay, which is 5 here. I think there is a AND graph which is missing. This is the AND graph. Okay, so that is the AND path. Okay, so either you go this OR path or you go in this direction of the AND path. Okay, so in the AND path case, what is the total cost? I told you in the AND case you have to take both. So this is 6 plus 4, the cost of the nodes, plus 2 edge costs, which is 1 plus 1, right? Plus 1 plus 1, which is equal to 12. So this is 12, this is 12, whereas this is simply 6, right? This is simply 6. Ideally we should choose this, right? In our solution, ideally we should choose that because that is the lowest path, 6. But then when we expand the graph further, we see that if we go to A, then we have another AND path here if you go to A. So in that case, the total cost becomes 5 plus 5, 5 plus 5, 10, plus 2, which is 12, okay, plus this one, the edge cost. So the total cost becomes 13. Okay. So in that case, when you revise the cost, actually this path is more costlier than this path. So you would choose the AND path. Think about it. In the book that I have uploaded, extra resources, there this explanation is there, okay, in detail. Okay, so it means that the principle of AO star is we revise the cost when we expand the graph further at the source itself, so that we know the best cost. Immediately it may not be clear whether we should follow the AND graph or the OR path, but the OR path may lead to some other AND path, which might make the whole solution costlier. That is the principle of A star. See, here it is written initial best cost is 6, but after D and E are expanded, the best cost becomes 12, the other one. Okay. Then the same thing is explained. The rest of the slides is explaining this concept of AO star. Okay. Summary of AO star algorithm. So with this we will conclude. The remaining slides you can read on your own. So what is the difference between A star and AO star? AO star algorithm is a variant of A star algorithm designed to be more adaptive and flexible. AO star builds on A star capabilities by allowing on the fly adjustments or cost revision whenever it encounters changes, making it ideal choice for scenarios where the situations are uncertain. That means we do not know what is beyond it. So we revise cost. Okay. So which algorithm should you use? A star or AO star? This can be a 2-mark question. Where you should use A star, where you should use AO star. So then your answer is this. Okay. And or graph AO star. So this example, you see the solution, and so we are not going to ask you this detailed solutions of using AO star. Okay, we will only ask smaller problems, but this one is one for illustration. The answer how it is being solved using AO star. Okay, so with this we stop.